Today we're going to look at the magnetic interaction between the drive coils and the projectile. We're also going to look at parallel IGBT switches on the drive stages. So I'm going to run two experiments. And the first round of experiments is with a large coil spacing between the drive coils. And then we're going to run a close spacing between the drive coils. And this is on the SCR stage. And we're going to check our velocity with a large spacing and a close spacing, as well as the waveforms. Also, I'm running two IGBTs in parallel. We're using a current limit resistor so we don't blow them out, and that shares the current between the transistors as well. A couple of different techniques here, and we'll see what kind of results we get on that. I revised an earlier drive board to operate with the photodiode triggers, and this was set up for the first three stages to be used with SCRs. So on our first stage, capacitance with the large spacing is 1470 microfarad. Stage 2, I trimmed it out and tuned it. That's 1040 microfarads. Last stage is 470 microfarads. So with three stages with the large spacing, 420 volts on the coils, we're doing right around about 100 feet per second. That's 99.4. That's about the average. I'll do a couple more runs. So here's our oscilloscope reading with the large spacing. There's our pickup loop. There's the oscilloscope waveform. 1 millisecond per division. For the next round of tests, I have removed the spacers between the coils. On the three SCR stages, everything is still the same capacitance, same coils, same everything. I just removed the spacer and watch the velocity difference. I will also state that the coils I'm using on this setup are the same ones I used in coil gun part 4. I just added one more layer of windings on the outside to increase the inductance. There's our velocity, 114 feet per second. This performs much better without those spacers between the coils. So I ran a few rounds through with a closer spacing, and I'm averaging about 110 feet per second. So that's a solid 10 feet per second over the previous setup. So here's our waveform on coil 2. That's 2.5 milliseconds per division and 1 millisecond per division. That's our pickup coil, same as it was with the wide spacing. So on this next experiment, we're going to increase the energy levels on the first 3 SCR driven stages. So I'm now running the capacitors in series. First stage is 1000 microfarads. Second stage is 500. Third stage is around 340 microfarads. Capacitors are in series, and we will be running at 800 volts input. There are our 3 SCR switches. Here goes the shot with 800 volts. This is 800 volts. That gives us 141.5. I have now energized the single IGBT stage with 290 volts. That's all I have, and the SCR drive is up to 800. Now let's see what happens. Here goes a shot with 800 volts on the SCRs and 300 volts on the IGBT. That's 149.7 feet per second with the IGBT stage turned on. That's 147.1. So as I finished up this experiment, coil number 3, last stage on the SCR, the spacer is on the wrong side. It should be towards the coil. So if I had that reversed, I'd probably gain another 5 feet per second at least. So with this setup, I should easily top 150 feet per second. And what I also have to improve on is the power supply for the IGBT stage. I have to increase the voltage on that. So if we can get that up to 400 volts, maybe we'll see some more improvements there.